Right. Then write down red color pen. Red color pen write down. Each resistor has the same potential difference. Each resistor has the same potential difference. That is equal to the potential difference across equivalent resistance. Potential difference across equivalent resistance. Next point also red color pen write down. The summation of current passing through. The summation of current passing through. The summation of current passing through. Each resistor is equal to. Each resistor is equal to current passing through equivalent resistor. Current passing through equivalent resistor. Current passing through equivalent resistor. Right. Look here, this story. Now then we notice two important points regarding resistors in parallel. The first important point is, as I explained already, when you consider potential difference across equivalent resistor, capital V, and also the potential difference across each resistor in parallel in the resistor system are same, right? Potential difference across R1 is also capital V, red minus blue. Potential difference across R resistor also capital V, red minus blue. Potential difference across R resistor also capital V, red minus blue. Potential difference across equivalent resistor also capital V, red minus blue. That's the first point. Second point is the current passing through the resistors in parallel. When you get the summation I1 plus I2 plus I3, that is going to be equal to the current passing through the equivalent resistor. That's the idea. Okay. So then the story. So you can mark now capital V potential difference in every resistor. Right? You can mark capital V potential difference. Capital V potential difference you can mark here if you want. Just mark it, okay? Just mark it here R3. Potential difference is capital V. And R2 also potential difference is capital V. R1 also potential difference is capital V. Right? So likewise mark that story. So then we know that when there is a current passing through a resistor, the potential difference across the resistor is capital V, then we can write down capital V equals IR. If there is a current capital I passing through a resistor of resistance capital R, the potential difference across that resistor can be given by V equals IR equation. Apply V equals IR equation for the equivalent resistor. Right, when you apply V equals IR for the equivalent resistor. V equals IR for the equivalent resistor. You can write down a potential difference across equivalent resistor, that is going to be capital V. Current passing through the equivalent resistor, that is going to be capital I. Equivalent resistance capital R. So then substitute capital I. Your capital I going to be equal to V over capital R. Equation 1. Now apply this V equals IR equation for the each resistor in the resistors in parallel circuit. If you apply for R1 resistor, then potential difference across R1 resistor going to be capital V. Current passing through R1 resistor going to be capital I1. Potential difference across R1 resistor going to be resistance of the resistance going to be R1. And substitute I1. I1 means we know that V over R1 is equation 2. Likewise, apply this Vico-Dyer equation for R2 and R3. Substitute I2, I3. Potential difference is V. Current is I2. The resistance going to be R2. So when you substitute I2, I2 going to be V over R2. Likewise, when you apply for R3 resistor, right, V equals current is I3, resistance R3. When you substitute I3, I3 going to be equal to V over R3. V over R3. This is going to be equation 4. Then what you can do, we all know that the current capital I must be equal to I1 plus I2 plus I3. That's what we know. So we know this story. So in the second, that second red color point, what we wrote, second red color, what we wrote that, second red color point, we wrote that summation of current passing through each resistor is equal to the current passing through the equivalent resistor. Below that point, if you have some space, below that point, write this one. I equals I1 plus I2 plus I3. Again, after writing the story, again write down I equals I1 plus I2 plus I3 and substitute. Right. If you substitute from equation 1 to 3, 4, you can obtain an equation for equivalent resistance. You can obtain an equation for equivalent resistance. I means we all know that V over R must be equal to I1 means we all know that V over R1. And I2 means we all know that V over R2. V over R3. Finally, all the V terms cancel out. Then we can write down equivalent resistance of a resistor system in parallel. Right? 1 over capital R. Right? 1 over capital R must be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Highlight this equation, very important. Very important equation. Very important equation. Highlight this equation, very important. Highlight. So once you finish writing up to here, raise your hands. So now, if the resistors are in series, the equation to find the equivalent resistance is capital R equals R1 plus R2 plus R3. When the resistors are in parallel, the equation to find the equivalent resistance is 1 over capital R equals 1 over R1, 1 over R2, 1 over R3. Finished. Finished. Right, okay. Sample question. Quickly find the equivalent resistance of below circuit. Sample question. Find the answer. Sample question. There are 3 resistors in parallel. So you want to find the equivalent resistance between the terminals A and B. They have given the resistance of this resistor 9 ohms. This can be 5 ohms. This is 1 ohms. Find the answer. Find the equivalent resistance. Find the equivalent resistance. Now then you want to substitute these values for this equation. Equivalent resistance of these resistors, that is capital R. We can write down 1 over capital R must be equal to 1 over capital R must be equal to 1 over R1, 1 over 9 plus 1 over 5 plus 1 over 1. So your target is to find the equivalent resistance capital R. That's your target. That's your target. Now what we can do? Now what we can do? Simplification. 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 So 1 over capital R. Common denominator. That is going to be, we can take 45 as a common denominator. If 45 is the common denominator, then here 5, it's going to be 9. 5, 9, here it's going to be 45. If I'm wrong, tell me. So then finally we can end up with 45 plus 5, 50, 50 plus 9, 59. 59 over 45 is 1 over capital R. Then we can find the equivalent resistance capital R must be equal to, capital R must be equal to how much? 45 over 59 ohms. Simplify it if you want, right? So likewise, sample question number 2, right? Let's find the equivalent resistance of this system. 4 ohms is going to be 5 ohms. Point capital A, point capital B. Find the answer. Find the answer. So then now there are two resistors in series or parallel. Always understand in a question whether resistors are in series or parallel. Now, according to this story, so you want to understand, you can color it, right? So without coloring, sometimes you are not able to, so you are not easily identify whether resistors are in series or parallel. Some questions, we will learn that questions today. Now, in this case, no doubt that these two are in parallel. No doubt, these two are in parallel. So if I ask you why, the answer must be, sir, when you consider 4 ohms or 5 ohms, these resistors are in parallel because the potential difference across 4 ohms and the potential difference across 5 ohms are same, sir. Why? How? For example, sir, if I take the voltage at a point somewhere here, this point voltage, right? This voltage remains same. This voltage remains same throughout this conductive path, right? This voltage remains same throughout this conductive path. Then all these points on this conductor, voltage going to be same. And till they meet the resistors. And also if I consider a point somewhere here, the voltage at this point remains same. The voltage at this point remains same through this conductive path till they meet resistor. Till they meet resistor. Then now see, look at the diagram, sir. Now when you look at the system, you understand that when you consider 4 ohm resistance, the potential difference is blue minus red. When you consider 5 ohm resistance, the potential difference is going to be blue minus red. We definitely then, potential difference across 4 ohms as well as potential difference across 5 ohms should be same. That means these two resistors are in parallel. In that case, if you want to find the equivalent resistance, you plot as an equation. 1 over capital R must be equal to 1 over capital R must be equal to, right? So 1 over 4 plus 1 over 5. So one can simplify this. 4 into 5 means 20. Then 20, here it's 5. 5 plus 4. Somehow you end up with 20 over 9 ohms as your equivalent resistance. But there's a short method when there are only 2 resistors in parallel. Now I'm going to teach you a method. That method is only applicable, only possible when there are only 2 resistors in your system and which are parallel. When there are 2 resistors in parallel, rather than obtain this equation 1 over capital R equals 1 over R1 plus 1 over R2, remember, there's a method you can find the equivalent resistance equals to multiplication of two resistances over addition of two resistances. Equal resistance equals to multiplication of two resistances over addition of two resistances. Addition of two resistances. Right? Okay. Look here, this idea. Special point. You can write this one, special point story. Right? Finish writing the story. Then I will teach you the special point. Finish writing, raise your hands. Then I will teach you the special point. Right. So I think you finished writing this one. Now I erase this one. Let's say this resistance is R1. And this resistance is going to be R2. If there are only two resistors which are parallel, then what you can do, you can obtain your equivalent resistance equals to multiplication of two resistances over addition of two resistances. Multiplication of two resistances over addition of two resistances. That's it. Now, what was your previous value? This is 4 ohms and 5 ohms. Then you got your equivalent resistance as it's what? What was the value? What was the value for the equivalent resistances? 2009 something. 2009 something. 2009 something. Now, now this is 4 ohms, this is 5 ohms. Then find the equivalent resistance following this story. Then also you're ending same answer. But multiply these two values. 4 ohms into 5 ohms, 20. 4 into 5, 20. 4 into 5, 20. 4 into 5, 20 over addition of these two resistances, 4 plus 5. 4 plus 5, 9. See, 20 over 9. 20 over 9. Same story. Same story. This is kind of, now whenever you better in your upcoming stories, whenever you see two resistors are in parallel, then use this equation. But this is not something magic. This is also derived from this fundamental equation. So if I show you how this is derived, so 1 over capital R must be equal to 1 over R1 plus 1 over R2. Right? 1 over R1 plus 1 over R2 must be equal to 1 over R1 plus 1 over R2. So then common denominator going to be R1 into R2. Common denominator going to be R1 into R2. And then this is R1 plus R2. I hope you understand. Am I correct? 1 over capital R. So it is the reciprocal. Then you can write down capital R must be equal to R1 into R2 over R1 plus R2. This is the idea. Right? So, Bhatni, very easy. If there are three resistors, more than two resistors, you can't use this method. R1 into R2 into R3 over R1 plus R2 plus R3. You can't apply like that. When there are more than two resistors in parallel, you have to go with this standard equation. 1 over R, 1 over R1 plus 1 over R2 plus 1 over R3. If there are more than two resistors, you have to go with standard equation. If you notice in your system, there are only two resistors in your system. Better you can apply multiplication or addition. Multiply the values over add the values. That's it. The story. And nearby, you can write this also proof. You can write this also. Special point 1. Special point 1. Special point 1. Finished answer? If you finished writing, raise your hands. Writing answer. And do this example. This is the special point one. Do this example. Example question. Find the equal resistance across terminals A and B. This is 25 ohms. This is 5 ohms. Find the answer. Example number one. Example number two. Example number two. This time you want to find the equivalent resistance between terminals A and B, and they have given this is 4 ohms, 4 ohms, 3 ohms, 6 ohms. This is 8 ohms, 4 ohms. This is going to be 7 ohms. Now we understand that in this circuit, in this resistor system, we notice that there are some resistors which seem like are in parallel. There are resistors which seem like in series. Okay, right? So my advice is just consider this 3 resistors system. So when you consider this 3 resistor system, raise your hands how many we say, sir, forget about the remaining. When we consider these 3 resistors in this system, these 3 resistors are in parallel and sum. Raise your hands how many we say, these 3 resistors are in parallel and sum. These 3 are in parallel. These 3 are in parallel. So when I consider these 2 resistors, I forgot about this story, forget about this. When you consider these 2 resistors are in parallel and sum, these 2 are in parallel and sum, these 2 are in parallel. So my advice is, in a resistor system, first of all, identify the branches. Identify the branches where you see resistors in parallel. Identify branches where you see resistors in series. Simplify that branch first. Sometimes your entire resistor system can be very complex system having plenty of resistors. But if you can identify some branches in the system, if you can identify some branches which are in parallel, which are in series, then give priority to simplify that branch and make it to one single resistor. So now we can understand, since these 3 are in parallel, I can simplify these 3. If I find the equivalent of these 3, I can brief into one single resistor. Rather than writing these resistors in parallel, rather than drawing these resistors in parallel, I can only draw a single resistor here. Likewise, if I can find the equivalent one, the single one, rather than drawing these resistors, I can represent these two by using a single resistor. First of all, give priority to find the equivalent of this one. Then I will do next story. So if I find the equivalent of these 3, let's say R, equivalent of these 3, let's say R. Then we know that It's R1. So 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. So then equivalent of these three, I take this point as point capital C, point capital C, this point going to be point capital D. This time I'm going to find the equivalent resistance between terminal A and C. I'm going to find the equivalent resistance between terminal A and C. So 1 over RAC. 1 over RAC must be going to be equal to, right? R1 is 4, R2 is 3, R3 is 6. 1 over 4 plus 1 over 3 plus 1 over 6. Right? Then the common denominator going to be how much? So we can consider common denominator as 12. We can consider common denominator as 12. If 12 is your common denominator, it's 3 plus it's going to be 4 plus it's going to be 2. Then simplification. 4 plus 3, 7 plus 2, 9. 9 over 12 equals 1 over RAC. 9 over 12 is 1 over RAC. RAC means 12 over 9. 12 over 9 means 4 over 3. Right? 4 over 3. RAC is 4 over 3 ohms. Now this part I done. I got this part. Equivalent resistance between terminal A and C. Right? Equivalent resistance between terminal A and C. RAC, I know it's 4 over 3 ohms. But my target is not finding the equivalent resistance between terminal A and C. My target is to find the equivalent resistance between point A and B. It's my target. Right? Likewise, can you find the equivalent resistance across point C and D? Then this is easy. If there are two resistors in parallel, I taught you a short method, multiply the magnitudes and then divide by the addition of these two magnitudes. Then RCD is a bit easy, not difficult. RCD going to be multiplication of these two 4 into 8. Automatically, you can no need to do the steps. You can just till 32 over 8 into 4 means 32 over 8 plus 4 means 12. 32 over 12. 32 over 12 means how much? 8 over 3, something like that. Multiplication of these two values over addition of these two values, 8 plus 4. Then we can write down 32 over 8 plus 4 means 12. 32 means 8. If you divide by 4, 32, 8 over 3 ohms. Right, okay. Right, okay. Now what I'm doing, see, rather than representing these three resistors in parallel, I can draw a single resistor between point A and point C. I can draw a single resistance between point A and point C to represent these three resistances in parallel. If I do it, here is my point capital A. Between point capital A and point capital C, the single resistance is going to be, because these three is equivalent to the single one. That is how much? That is 4 over 3. This is 4 over 3. Am I correct? So then between point C and D, the equivalent resistance is going to be how much? 8 over 3. C and D. 8 over 3. 4 over 3 ohms. This is 8 over 3 ohms. Between point D and point B. Between point D and point B. This one going to be 7 ohms. Now, when you consider this 4 over 3 ohms, 8 over 3 ohms, and 7 ohms, raise your hands. These three are in series and these three are in series and now these three are in series. If they are in series, if you want to find the equivalent resistance between point A and point B, I told you just add them together because when resistors are in series, you want to add them to find the equivalent resistance R1 plus R2 plus R3. Then you can write the equivalent resistance equals what? Equivalent resistance equals capital R equals 4 over 3 plus 8 over 3 plus 7. Simple. I think now you understood this pattern. This is what applicable in every complex resistor systems. This is what applied. So when you simplify this, then here common denominator going to be 3. Then here it's 4 plus 3 plus here 21. Right? 21. Then 21 plus 3 means 24, 28 over 3. 28 over 3 ohms. Done? Right, okay. I think now we have an understanding about the resistors in parallel. So that story is okay. Now we'll do some special points. The second special point. Finish writing till your answer. Finish writing till your issuance. If you finished writing till their issuance. If you finish writing till their issuance. Right. Okay. Now special point number 2. Special point number 2. Look at this idea. I list this board. Special point number 2. Let's say now there are resistors which are in parallel. But this time the resistances are equal. There are resistors which have same resistances are in parallel. Right? Yeah, magnitude is the same. Right? Let's just consider there are simple in number of resistors in parallel. There are simple in number of resistors in parallel. There are simple in number of resistors in parallel which have same resistance. Likewise, there are simple in number of resistors which have same resistance. In that case, how can you find the equivalent resistance? Resistance of each resistor going to be capital R. Resistance of each resistor going to be capital R. Capital R. Now these are in parallel. So you can derive it. This is point capital A, terminal capital B. Remember in this case, what we do, if you want to find the equivalent resistance, remember, equivalent resistance is going to be equal to resistance of one resistor over number of resistors. Can you remember when resistors are in series? If there are simple number of resistors are in series having equal magnitude, having equal resistance capital R, in order to find the equivalent resistance, what have we done? We multiplied number of resistors by the resistance of one resistor. If the resistors are in series. So therefore we got that R equivalent equals capital R into simple N. But in this case also same story, but this time resistors are in parallel, having same magnitude, having same resistance capital R. There are simple in number of resistors in parallel. In that case, if you want to find the equivalent resistance, if you want to find the equivalent resistance of this resistor system, that is going to be resistance of one resistor capital R over a number of resistors simple in. Very important equation. Special point number 2, very important equation. Very important equation. For an example, right? Let's consider now There are three resistors in parallel. There are three resistors in parallel. There are three resistors in parallel. Having magnitudes 3 ohms, 3 ohms, 3 ohms, if not 6 ohms, 6 ohms, 6 ohms. Their resistance 6 ohms. We understood that there are three resistors in parallel having same resistance 6 ohms. If I want to find the equivalent resistance, if I want to find the equal resistance, that is equal to resistance of one resistor 6 over number of resistors in parallel 1, 2, 3. Our equivalent resistance is going to be 6 over 3 means 2 ohms. Very simple. Now you can use that equation. 1 over capital R, 1 over equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. 1 over 6 plus 1 over 6 plus 1 over 6 must be equal to 1 over R equivalent. When you simplify it, this is what you will get. Right? This story. Then example number 2. Example number 2. Example number 2. There are two resistors in parallel. Each having resistance 4 ohms, 4 ohms. What is the equivalent one? Right? Within a second, you should be able to answer. When there are two resistors in parallel, having equal magnitude 4 ohms, 4 ohms, your equivalent resistance must be how much? It's going to be 2 ohms. 4 ohms, 4 ohms. Equivalent going to be 4 over 2 means 2 ohms. That's the idea. That's the idea. That's the idea. You should remember all these points, then only you can simplify a circuit. Write down the point below that now. Special point number 2, we drew the circuit and I explained. Write down if there are simple in number of resistors in parallel. If there are simple in number of resistors in parallel. If there are simple number of resistors in parallel. If there are simple number of resistors in parallel. Having equal resistance capital R. Having equal resistance capital R. Comma, then the equivalent resistance is found by. Then the equivalent resistance is found by. Then the equivalent resistance is found by dividing magnitude of one resistor by magnitude of one resistor by number of resistances, number of resistors, dividing magnitude of one dividing magnitude of one resistor, magnitude of one resistance by number of resistors, dividing magnitude of one resistance by number of resistors. That's totally clear. Now I think this is the overall fundamental theory points regarding resistors in series and resistors in parallel. By using this knowledge, I think now you should be able to find the equivalent resistance of different types of complex resistor circuits. Now just quickly find the equivalent resistance of the resistor circuits between A and B. Right? Now you have to keep on doing. I have to keep on doing. Right, number 1. Put your number 1. We'll solve these stories. We'll solve these resistor systems equivalent resistance. Number 1. Number 1. Some diagrams seem very tricky. Okay, but you should be able to identify and you should be able to properly sort it out. The only thing is identifying what are in series and what are in parallel. So then problem solved. Then here you have so your terminals are point capital A and B. You want to find the equivalent resistance between terminal A and terminal B. Terminal A and terminal B. Find the equivalent resistance. Now they have given resistance of each resistor going to be 20. 20. It's 20 ohm. 20 ohm. 20. 20. 20 ohms. Number one. Then number two, terminal A. Terminal A. Terminal B. Resistors. 4 ohms. You mention ohm symbol. Then here 6 ohms. And then here 8 ohms. And here 8 ohms. And here 8 ohms. And then here 4 ohms. 4 ohms. Terminal B, A, 4, 8, 6. Right? Sorry, here there is another one. Yeah, 6, 4. Okay, correct. Answer, Vaman, if you finish doing first one answer. First one finished answer. Anyone finish first one answer? First one finished answer. Always catch 2 points. Always catch 2 points and check the resistors in between those 2 points are in series or parallel. Always select 2 points. And always select 2 points and check the resistors in between those 2 points are in series or parallel. That's what you want to do. That's what you want to do. Hands up. Anyone finished first one? Hands up. First one finished. Hands up. First one finished. Still doing answer. Still doing answer. Still doing. So parallel, I do the third one also. Third one is very similar to the previous one of the previous examples. there's a resistor here, but okay, no need. There's a one here. Here, as a resistor, it's 1/3, yeah, 103 ohms. Then here it's 1, and here it's 2 and 2. Terminal A is here. Terminal B is here. You should find the equivalent resistance between AB. Anyone finished first one answer? First one finished answer. First one finished answer. Now here see. Now you want to find the equivalent resistance between point A and B, right? Now select this point and you can select any 2 points. You can select any 2 points. Now I select these 2 points. If you select these 2 points, ratio and sum we say. If we select these 2 points, ratio and sum we say, these two resistors are in series and sum. If we select these 2 points, ratio and sum we say, these two resistors are in series and sum. Seriously, then what we can do, sir, when you consider this point and this point, these two are in series. In that case, equivalent of these two will be 20 plus 20, 40. Right? What can I do? Rather than keeping these two, I can replace these two by 40 ohm single resistor. 40 ohm single resistor. Right? Is 40 ohms. Now okay. Now see, but always remember, sometimes when you do the modification like this. So when you're removing resistors, when you're replacing resistors with equivalent resistance, sometimes what will happen, without knowing yourself, automatically what happens, you remove these two terminals also. Right? Now you will understand when you do the questions. Sometimes when you are find like when you are selecting 2 points and when you're replacing the setup with equivalent resistances, automatically sometimes those two terminals A and B also removed. But you want to ensure till the last, till the end, you should ensure remaining those two terminals where you are going to find the equivalent resistance. That's very important, right? That's very important, right? Now point I want to find AB resistance. This is 40. Now shall we take another 2 points? Shall we take another 2 points? One can take these 2 points. One can take these 2 points. If not, one can take this point and this point, this branch. If one consider here to this point branch, ratio and sum we say. So if we consider here to this branch, there are 3 resistors, 20, 20, 20. Ratio and how many we say? If we consider this branch here to here, these 3 resistors are in parallel and series and sum. These resistors are in series and sum. These 3 are in series and sum. So if we select the points in different ways, won't we get different answers? No. You should get same answer. Same answer. Right. If I select, now one can consider these 2 points and 20 plus 20 is 40. These two and series, these two and series, 20 plus 20, 40. Right. Okay. Can do different ways. Okay. Now 20, 20. Now I consider these 2 points, this point and this point. Then 20, 20 is in series. Then the equivalent is how much? 40. Equivalent is 40. Equivalent is 40. Then right, 40. Right, some more simplified a little bit. Now look here. When you consider these two, just consider this branch here to this branch. Then you want to understand. If not, same current flowing branch. I told you if resistors are in series, same current passes through the resistors. Right? If the resistors are in series, same current passes to the resistor. For an example, if you consider current passing from capital A, this current is breaking into 2 parts. Right? Whatever the current passing through, this I1 current passing through 20, same I1 current passing through 40. Simply you want to understand then these two are in series. These two are in series, right? So then what can I do? I can replace these two by between these two terminals. Between these two terminals, these two are in series. The 20 plus 40 means result is 60. So what can I do? I can draw a 60 ohm resistor. Between those two terminals, I can draw a 60 ohm resistor. I can remove these two now. Simplified. But still not finished. Still not finished. Still not finished. Now between this is point A. This is a wires, right? These are wires. You can flex it as the way that you prefer. You can bend the wires as the way that you want to see the circuit. You can change the shape of the circuit. That's what I want to say. Now, what can you see here? What can you see here? 60 ohm is here. This 40 ohm. This 40 ohm. This 60 ohm. Raise your hand, someone if you see. This 40 ohm and 60. They are parallel answer. 40 and 60 parallel answer. 40 and 60 parallel. They are parallel, right? Very simple. Why? So between these 2 points, this is 60. This is parallel. Parallel. Just bend the wire the way that you prefer. You can bend the wire the way you prefer. If you bend the wire, you understand that these two are parallel. If these two are parallel, now then you can summarize it between point A and point B. Between point A and your point B, this is equivalent to 60 ohm over 60 ohm and other one is 40. Other one is 40. This is your point B. So you can bend the wire the way that you prefer. You can bend the wire the way you prefer. You can bend the wire. Okay. Then the equivalent is how much? R equivalent. Equivalent resistance. Equivalent resistance is going to be how much? I told you, when there are two resistors in parallel, multiplication, division over addition. Multiplication over addition. 60 into 40 over 60 plus 40. Our answer going to be 60 into 40 means 24. 2400 over 100. That means 24 ohms. This is the way. This is the way. Hands up. Anyone finish? Second one, hands up. Question number 2 finished, hands up. Question number 2 finished, hands up. Just do it. So I'll draw a few more questions. So this is the section. Then first part is finished in electricity. So we'll do lots of questions. Next one is fourth one. 1, 2, 3. Two, 3, 6, 1. Sometimes some resistors seem like parallel. That is a kind of trap. Sometimes some people think some resistors seem like parallel, but that is seem like parallel. That's kind of trap. That's a kind of trap. Huh? If they are parallel, you know the condition. If they are parallel, remember, see the story. See here. See here. If these three are parallel, see the story. If these three are parallel, they should have connected to same 2 points. If these three are parallel, these three should have connected between same 2 points. For example, see, for example, see, 6 ohm. The 6 ohm is connected to terminal A and terminal B, right? So you can remove this wire and you can keep like this. So this 6 ohm also connected between terminal A and terminal B. The 6 ohm also connected between terminal A and terminal B. So remember, if resistors are in parallel, they should have connected to same 2 terminals. Sometimes in the circuit, they look like parallel. So you want to check that. For an example, see, these two are parallel, look like parallel. These two look like parallel. But you want to ensure how they connected between two same points. This one is here, this one is here, this one's terminals are here and here, this one's terminals here and here. Intermediate, there are resistors. Therefore, you can tell that these two have not connected between same 2 points. These two we can't consider as parallel. Likewise, there are some stories. Hands up, how many finished? Second one, hands up. Second finished, hands up. Question number 2, finished, hands up. How many finished? 2 hands up. Finished, 2 hands up. Quickly do, huh? Should do quickly. Should do quickly. Find the answers. How many of you finished? Second one, hands up. Second finished, hands up. Second finished, hands up. Number 2 finished, hands up. Only 2. Right. Now see, now I want to find this is my point B, yeah. I want to find the resultant equivalent resistance between A and B. Then you can start from anywhere. You can start from anywhere. You should select 2 points and you should simplify the resistance between those 2 points. Select 2 points and simplify the resistances between those 2 points. Now one can select different, there are different stories. Now see, one can start from these 2 points. So one can start from these 2 points, right? So then you want to understand, if you consider these 2 points, what are the resistors between these 2 points? 8 ohm is between these 2 points. This 8 ohm also between these 2 points. Then you notice further, these two 8 ohms are in parallel. If these two are in parallel, what is the equivalent of these two? 8 over 2. 8 over 2. 4 ohms. I told you that when there are two resistors having equal magnitude, if you want to find the equivalent resistance, 8 over 2. That's what I know explained here. Then what you can do, you can tell 8 over 2 means 4 ohms. So between these 2 points, equivalent resistance is going to be 4 ohms. Equivalent resistance is going to be 4 ohms. Now, again one can consider between this point and this point. Again, between these 2 points, 4 resistors between these 2 points, 4 ohm is here, and between these 2 points, this 4 ohm is here. This 4 ohm, they are in parallel. I hope you understand. Again, 4 and 4 parallel. What is the equivalent of these two? 4 over 2. It's 2 ohms. Between these 2 points is 2 ohms. It's 2 ohms. Very careful, listen. Now simplify it. Likewise, you can simplify further. Now then you can consider this point and this point. So when you consider this point and this point, if you consider these 2 points, what are resistors between these 2 points? Here and here means this 4 and 6. They are in series. This 6 and this 4 and series. Am I correct? These 2 and series. 6 plus 4 means how much? 6 plus 4 means how much? 10. 6 plus 4 means 10. Then instead of these two, between these 2 points, you can replace these two resistors by 10 ohms. Oh God. Right? 10 ohms. See the story. 10 ohms. Now see, now what can I say about between these 2 points? So when you consider these 2 points, 8 ohm is there, 10 ohm is there. Then 8 and 10 are again parallel. 8 and 10 are parallel. Am I correct? 8 and 10 are parallel. Then you know how to find the equivalent between these two. The equivalent going to be 8 and 10 parallel. Equivalent of these two going to be 8 into 10 over 8 into 10 over 8 plus 10. 8 plus 10. Here that means 80 over 18. 80 over 18. If I divide by 2, 40 over 9 something. 40 over 9 something. All right. See, so then I can remove these two. When you consider these two are in parallel, you can replace these two by 40 over 9 ohm single resistor. 40 over 9 single resistor. 40 over 9. Simple. Finally, between A and B, 4 ohms, 40 over 9 ohms plus 2 ohms. Sorry, 2 ohms. These three are, see, these three are in series. These three are in series. Bend the wire like this. If you bend this wire to the vertically upwards, very simple. If you bend this wire from this point, if you bend this wire upwards, the point will be here. Here is your 4 ohms. Am I correct? If you bend this wire to down, it's going to be point B is here, it's 2 ohms. Right? So then 40 over 9, 2, they are in what series? So no need to do like this. You want to understand by looking this setup. 40 over 9, 2 are in series. Then you can tell that R equivalent equals 4 plus 2 is 6. 6 plus 40 over 9. So when you simplify, 9 now. Yeah, 9 into 6 means 54. 54 plus 40. 54 plus 40 means 94 something ohms. Generally, hands up. Question number 2 is very clear, hands up. Question number 2 is very clear, hands up. Question number 2, idea is very clear, hands up. How many of you understand question number 2, idea? Question number 2, idea, understand, answer. Likewise, how many of you finished doing third one, fourth one, 3, 4 finished answer? 3 and 4 finished answer? 3, 4 finished. 5 finished answer? 5 also finished. Just do it. Right? I'll come. Keep doing. Next story. Next question number 3. In third one is very similar question that we discussed already. Then these two are in parallel. Equivalent of these two will be 1 into 2 over 1 plus 2. That means the equivalent of these three going to be 2 over 3 something. 2 over 3 ohms. 2 over 3. And then this 3 ohms, 2 over 3 ohms, 1 over 3 ohms, these three are in parallel. We'll come to the story later. We'll catch these three in parallel. Sorry, these three are in series. So we'll catch these three later. These three are in parallel. Look at the story. Now see the trick. See, some of you might do in order to find the equivalent of these three. Some of you might apply the equation 1 over r equals 1 over 1 plus 1 over 2 plus 1 over 3 something. But no need to do like that. Now look at these two. Yeah, these three and parallel, I agree. These three and parallel, I agree. So you can apply the equation 1 over r equals 1 over 1 plus 1 over 2 plus 1 over 2, and you can simplify it and you can find the equivalent of these three. You can do that. But look at here, these two. These two are also in parallel. So when these two are in parallel, what is the equivalent of these two? 2, 2. Equivalent to these two is how much? Equivalent to these two going to be 1, right? When you consider one magnitude, if you divide by number of resistors, there are 2 over 2, 1. So when you consider these two resistors are in parallel, the equivalent of these two going to be 1. Now 1, 1 again. Again, this one and this one parallel. What should be the equivalent of these two? Half. Half. Again, finally, these four are in series. These four are in series. Addition. Equivalent going to be how much? Equivalent going to be 3 plus 2 over 3 plus 1 over 3 plus half. Simplify this one, then 2 over 3 plus 1 over 3 means 2 over 3 plus 1 over 3 means it's 3 over 3. 3 over 3 means 1. 3 over 3 means 1. 3 plus 1 plus half. 3 plus 1 means 4. 3 plus 1 means 4. 4 plus half means 4.5 something. 4.5 ohm something. 4.5 ohm. Likewise, keep on doing. I'll give more questions. I'll give more questions. Keep on doing. Keep on doing. And this in seventh one also somewhat similar. 4 half. This is sorry. Right. This is 2. This is 3. And then 2, 2. And here it's 2. And here also it's 2. And this is 4. 4. Find the answers. Find the answer. Find the answers. Now here, question number 1 to these discussed. The fourth one is also simple. You see, these 3 are in series. I don't want to explain. 2 plus 1 plus 3. These 3 are in series. Equivalent of these 3 going to be 2 plus 1 plus 3, 6 ohms. 6 ohms. And then these two going to be parallel. 6, 6. Equivalent of these two going to be 3 ohms. Then the equivalent resistance between A and B going to be 3 ohms. And this is a very simple story. See this idea. When you consider these 2 points, equivalent is 1 ohms. When you consider these 2 points, equivalent is 2 ohms. Right. And then when you consider these 3 points, so these 2 points, there are 3 resistors in series. These 3 are in series. Equivalent between these 2 points, 3 ohms. Right. And then when you consider these 4 resistors between these 2 points, these 4 are in series. Equivalent going to be 4 ohms. 1 plus 1 plus 1 plus 1. Equivalent going to be 4 ohms. Very simple. Very simple. Finally, we are getting something. Look here. Look here. This between these 2 points, these 2 are in parallel. So before what you can understand, these 4 are in parallel. How many of you understood? How many of you agree that these 4 are in parallel answer? How many of you agree these 4 are in parallel answer? How many of you see these 4 in parallel? Anyone? If you didn't understand, ask me. Just raise your hands. How many of you say these 4 are in parallel answer? 1, 2, 3, 4 ohms are in parallel answer. Didn't understand, sir? Didn't understand. Right? These 4 in parallel. Then if you can find the equivalent. So 1 over R going to be equivalent to 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So you're going to simplify. When you simplify, common denominator going to be 12. Common denominator going to be 12 right here. So 1 over capital R must be equal to 12. Then here it's 12 plus here it's 6. Here it's 4. Here it's 3. If I'm wrong, tell me. If I'm wrong, tell me. Then 12 plus 6 means 18 plus 4, 22. 22 plus 3 means 25 over 12 is 1 over R. Your R going to be 12 over 25 ohms. And so up to now, we have done 5 questions. Up to now, everything is very clear answer. Up to now, everything is very clear answer. Up to now, everything is very clear answer. Right. Okay. Then next story. Answer who finished? Who's doing 6th answer still? Doing 6th one still answer? Doing 6th one still. Okay, do 6 then 7. 6 and 7. I will put you more. I'll put more to 6 and 7. The next one is six, six. This is 6 ohms. If you can't see 6 ohms, this is 6 ohms. 6, 7, it's 10 ohms. Uh, 10 ohm. Right. This is going to be 5. This is going to be 10. Find the equivalent. The next one. ఇవ్వండి. Find the answers. Find the answers. So after finishing this 10, we'll take a small break. Hands up who finished. 6 finished hands up. 6 finished hands up. 6 finished. 7 finished. Right. I'm also doing these stories. See. Take 2 points. So better you can take up 2 points away from A and B. Right. So if I take 2 points, these two. If I take these 2 points, these two are parallel. Then the equivalent of these two going to be 1, 1, equivalent of these two going to be half. Then see these two. Between these 2 points, these two in series. Half plus half, 1. Then between these 2 points again, these two parallel. Equivalent 2 into 1 over 2 plus 1, 3. It's all done. If not equivalent to these two will be 2 into 1 over 2 plus 1. 2 over 3. Now, between these 2 points, these two, between these 2 points, these two in series, half plus 3 over 2. Plus 3 over 2, how much? Half plus 3 over 2 means we are getting here 4 over 2. 4 over 2 means just 2. The equivalent of these two going to be just 2. These two, again parallel. Again parallel. Then the equivalent of these two going to be 1 into 2 over 1 plus 2. 3, 2 over 3. Equivalent going to be 2 over 3. Hands up, this story clear, hands up. This question's clear, hands up to 6. Hands up, everything is very clear. Everything is very clear, hands up. Everything is very clear, hands up. Everything is very clear. If you have doubts, ask. Right. Then next one. Hands up, how many of you tried 7, hands up? How many of you tried 7 1? I'm trying, I tried 7 1, hands up. I'm trying, I tried 7. Sir, please explain 6 again. Right, 6 again. Okay, should draw it again. Not difficult. Same story. One, it's very interesting. If you interestingly do, also 1. And here is half. And here, it's again half. Right? That's it. You want to find the equivalent. Right? Just consider these 2 points. If you consider these 2 points, these two going to be parallel, right? This one norm and this one norm are parallel. These two are parallel. Then what is the equivalent to these two? Should be half. Equivalent of this should be half because 1 over 2. I told you this idea why it's 1 over 2. If there are 2 resistors in parallel having magnitude 1 1, the result is going to be 1 over 2. Okay. Now next, the next what 2 points? This point and this point, right? Now there is 2 also. I forgot this 2. There is 2 also, right? Now these two, between these 2 points, these two are in series, half and half. What is the equivalent of these two? Half plus half means 1. Now look at here. Now again look at these 2 points again, same 2 points. This 2 and this 1. If you consider these 2 points, there are 2 resistors. This 2 ohms and this 1 ohms. What can you say about these 2 ohms and 1 ohms? They are in parallel. They are in parallel. The equivalent is how much? 2 into 1 over 2 plus 1. 2 into 1 over 2 plus 1. That means 2 over 3. It's 2 over 3. It's 2 over 3. Right? It's 2 over 3. I made a mistake. Did I do a mistake? Am I correct? I think earlier I had a mistake. Earlier I think I had a mistake. Someone tell me that earlier I think I had a small mistake. Alright, yes, that's the thing. Yes, this is 2 over 3. Then these two, between these 2 points, these two are in series. Half plus 2 over 3. Half plus 2 over 3. Then the resultant going to be equivalent going to be here it's 6. 3 plus 4 7 7 over 6. 6. 7 over 6. 7 over 6. Again, this 1 and 7 over 6 parallel. Then 1 into 7 over 6 over 1 plus 7 over 6. If you simplify, you get the answer. If you simplify, you get the answer. The answer going to be 7 over 6 division 13 7 over 13 is your answer. Now clear? Now clear, right? Right. Now clear. Anyone finished 8 on answer? 8 finished answer? 8 finished. How many of you finished 8 on answer? Doing 8 answer? Doing 8? Right. Now here see these two. Now if not, one can consider these two in the beginning. If not, one can consider these two. It's up to you. And if I consider these two, okay, if I consider these two, between these 2 points, if I consider these two, 2 ohms and 2 ohms, they are in series. The equivalent of these two going to be 4. Am I correct? The equivalent of these two going to be 4. Right? Then see, again when you consider these 2 points, if not one, okay, again when you consider these 2 points, this 4 and this 4, they are in parallel. These two are in parallel. The equivalent of these two going to be 2 ohms. Right? Now consider between these 2 points. Between these 2 points, there are 2 resistors, 2 ohms and 2 ohms. They are in parallel. These two are in parallel. What is the equivalent of these two? 1 ohms. Now, between these 2 points, these two are in series. 1 plus 2, 3. 1 plus 2, 3. 1 plus 2, 3. 3. It's 3. Then again these two are parallel. Between these 2 points, these two are in parallel. 3, 3. How much? 3 over 2. Equivalent is 3 over 2. And then between these 2 points, these 3 are in series. Half plus 3 over 2 plus 2. Half plus 3 over 2 plus 2. If I simplify these two, 4 over 2 plus 2. Then 4 over 2 means just 2 plus 2 means 4. It's 4. Finally, the last one. Between A and B, these two are parallel. Answer going to be 2 ohms. Hands up, up now everything is correct. Hands up. How many of you got everything correct? Hands up so far? How many of you got everything correct? Hands up. How many of you understood everything? Hands up genuinely. How many of you understood everything? Hands up genuinely. Understood genuinely? Hands up. Genuinely understood? Hands up. Genuinely understood? Hands up. Okay. Right. 8:19. We will take a small break also. 8:19. 8:1. See here. 6 cents between these 2 points. These two parallel. 6 and 6 parallel. Equal is 3. Between these 2 points. 7 and 3 series. 10. Between these 2 points, there are 2 resistors, 10 ohms, parallel. Equivalent is 10 parallel means 5 ohms. Between these 2 points, 5 series, 10 ohms. Between these 2 points, 10 ohms, 10 ohms, parallel, 5 ohms. Here, again 2 points. Look here. Between these 2 points, these two, series, 2 plus 4, 6. 2 plus 4, 6. Right? Between these 2 points, same 2 points, these two. 3 between these 2 points, 6 between these 2 points. 6 and 3 parallel. 6 and 3 parallel. 6 into 3, 6 plus 3. Yeah, 18 over 9. That means 2 ohms. The equivalent of these two going to be 2 ohms. Just 2 ohms. This side, between these 2 points, these two in series, 5 plus 15, 20. These two, between these 2 points, there are two resistors, 20, 20. Between these 2 points, 20, 20, equivalent going to be 10. Equivalent going to be 10. Finally, point is here, 2 ohms, 3 ohms, 10 ohms. Point B is here, series, 2, 3 and 10 series. Then 2 plus 3, 5, 5 plus 10, 15 ohms. Nice story. Now this one, right, we'll do this one after taking a break. Time is almost 9 o'clock. We'll take a 10 to 15-minute break maximum. I will come at maybe 9, 12. I maybe come at 9, 12 something, maybe. Right? Take a break and come. Again, we have to do the, there are a few more stories to be explained. Take a break and come. Yes. Right. Okay. This one. Question number 10. 10th one. 10th one. See now, will you notice between the two terminals? Between the two terminals, where you want to find the equivalent resistance, right? So when you consider the line connecting two terminals, when you consider the line connecting two terminals, right? Both sides. If you see the resistor system is symmetrical. Now see, you want to find the equivalent resistance between point capital A and point capital B. This is the line connecting terminals A and B. Whether or not is your resistor system is symmetric around this axis. Correct me? Both sides from this axis, the resistor system is symmetric. See, same resistor system in both sides. In that case, what you do, if you notice your resistor system is symmetric, in that case, find the equivalent resistance in one side. Right? I thought of finding the equivalent resistance between point capital B and point capital A in the left side of the system. Right? So if I find the left side of the system, look here, these three, between these 2 points, see the idea? Between these 2 points, 2 ohms, 2 ohms, 2 ohms, they are in series. Am I correct? Between these 2 points, these three are in series. 2 ohms, 2 ohms, 2 ohms are in series. Equivalent of these three going to be 6 ohms. 6 ohms. When you consider 6 and 3 ohms, when you consider 6 and 3 ohms, between those 2 points, these two are in parallel. Equivalent of these two going to be 6 into 3, 6 over 3. So 6 into 3, 6 plus 3. That means 18 over 9, that means 2 ohms. The equivalent resistance between these 2 points is going to be 2 ohms. It's going to be 2 ohms. Right? Now this point, this 2 ohms, this 8 ohms, see, right? 2 ohms from this point, 2 ohms, 8 ohms, 2 ohms, 8 ohms. These four are in series. 8, 2, 8, 2. They are in series. So what can I do? 2, 8, 2, 8. They are in series. I can write the equivalent. 8 plus 2, 10. 10 plus 8, 18. 18 plus 2, 20. 20. 20. So then I can write down between point capital B and point capital A, the equivalent going to be 20. 20. Then I said that if you are a resistor system is symmetric around the terminals A and B, if both sides from the axis AB, if you notice your system is symmetric, find the equivalent resistance in one side. So I found equivalent resistance in the left side is 20 ohms. Again, when you simplify the right side resistor system, again you will end up with same 20. Am I correct? If you simplify this, you will end up with same as 20. You will end up with same as 20. Then what is the equivalent of these 20, 20? This 20, this 20, they are parallel. Your equivalent going to be 10 ohms. Hands up, this question is clear answer. This question is clear answer. This question is clear, raise your hands. Do you understand? This story is clear answer. This story is clear. Right? Now likewise, finish writing, raise your hands. We'll write a small point. Once you finish writing, raise your hands. We'll write a small point. Once you finish writing, raise your hands. We'll write a small point. We'll write a small point. Once you finished, hands up. We'll write a small point. Quickly finish it. It's 9:20. Once you finish, raise your hands. Finished? Others? Quickly. Right, finished. Eh? Okay. Now write down a small story. Write down. Write down. Write down. Finding the equivalent resistance of a network. Finding the equivalent resistance of a network. The topic, finding the equivalent resistance of a network. First point, write down. Write down. Be careful between which 2 points? Be careful between which 2 points? To look for the equivalent resistance. To look for the equivalent resistance. Right? Continue, full stop and continue. No trivialization. No trivialization should be continued. No trivialization should. No trivialization should eliminate those 2 points. Eliminate those 2 points. No trivialization should eliminate those 2 points. I told you that when you are finding the equivalent resistance, sometimes mistakenly you remove the 2 points where you want to find the equivalent resistance. You just remove point A and B. Sometimes that will happen in upcoming systems or resistors. Sometimes that will happen. But you want to ensure when you're simplifying the resistor system, you should somehow maintain the terminals A and B, the terminals where you want to find the equal resistance. You want to maintain till the last. Till the last. You should not eliminate the terminals A and B in the middle steps. But this is the point that I explained. Next point, write down. If there are resistors in series or parallel, if there are resistors in series or parallel, if there are resistors in series or parallel, comma, minimize them, comma, minimize them. Comma, minimize them. Next point, write down. Current does not flow. Current does not flow. Current does not flow through circuit parts. Current does not flow through circuit parts. Inside the bracket, write down called as loops. Current does not flow through circuit parts. Inside the bracket, write down called as loops. Close the bracket. That starts at one point in a circuit and that starts at one point in a circuit and return to its same point. Return to same point. Return to the same point. Return to the same point. Inside the bracket, write down not connected anywhere else. not connected anywhere else. Close the bracket. Full stop. Such loops can be removed from the circuit. Such loops can be removed from the circuit. Such loops can be removed from the circuit. It's a very important point. Such loops can be removed from the circuits. That's a very important story. Look here. This is important. Now we want to understand what does it mean by a loop in a circuit. What does it mean by a loop in a circuit? Remember, in a circuit, when you notice some sub-circuits may have resistances, sometimes may not have resistances. In a main circuit, there are some sub-circuits. The point where it starts and the point where it finishes are same. In that sub-circuit has not connected anywhere to the circuit. Right? I will explain like this. Now just consider what is a loop. What is a loop means? Now just consider there is a resistor system. Now here this is for an example 4 ohms and this is let's say 3 ohms. This is 2 ohms. This is 3 ohms. And you notice that there is another circuit. See the story. Right? This is again 4 ohms. For example, 5 ohms. Look at this blue color circuit very carefully. This is again 2 ohms. See the blue color circuit. So when you consider blue color circuit, now I want to find the equivalent resistance between point capital A and point capital B. This is my entire circuit. You can identify that's a kind of small sub-circuit. Specifically, when you carefully look at the sub-circuit, you notice that this sub-circuit started with the same point and sub-circuit is finishing the same point. In between, other than this point, this sub-circuit has not connected. This sub-circuit has not connected to the circuit from any point. Other than this point, starting point and ending point is same. This sub-circuit has not connected to the main circuit other than this point. The only point that is sub-circuit connected to the main circuit is this point. Right? If you notice, this sub-circuit is not connected to the circuit in other points. Remember, we can call this as a loop. So we can consider this blue color circuit as a loop. Blue color circuit is a loop. So they are telling if it is a loop, you can remove the loop from the circuit. You can remove the loop. So you can remove the loop. Then when you remove the loop, what you are getting? Your system will be simplified. Your system will be simplified. Simplified will. This is your system then. Right. Point A, point B, and 4 ohms. And here it's 2 ohms. This is going to be 3 ohms. I hope you understood what does it mean by a loop. So then the equivalent going to be how much? The equivalent resistance RAB going to be equal to how much? That is going to be equal to 4 plus 3 plus 2, 9 ohms. That story I think very clear. Right? So how do you identify a loop? You should understand that it has connected to the main circuit only from one point. It has not connected to the main circuit other than one point. Right? This loop starts and loops finishes the same point. Only that point only connected to the main circuit. When you consider the loop other than that point, loop has not connected to the main circuit from any other point. That is the idea. Then you can remove the loop story, right? Now simplify this one. Now remember, these are wires. These are kind of wires you can bend like your copper cable. Like you can bend the wires the way that you want, and you can form the shape that you prefer. Right? Sometimes they give the circuits while you should bend it. Then only you can get the right idea. Right? This question. This question. A nice story. It's a nice story. Nice story. Right. These are wires, right? You can bend the way that you prefer. It's up to you. Uh, Here is your point B. These are wires, huh? This point capital A. And they have given resistors 10 ohms, 10 ohms. 10 ohms. And they have given here it's 5 ohms. 5 ohms. And they have given this 20 ohms. Now here you can find a loop. Check where is the loop, huh? Here you can find a loop if you properly look it. You can find a loop. You can find a loop. But remember, your two terminals should not be removed, huh? Your terminals should not be removed. And next one. Next one is also something similar to that. So here, this is your point capital B, and your point capital A is somewhere here. And then the resistances here is 6 ohms, and here is 6 ohms, and then here is 4 ohms, and here also 4 ohms, and 2 ohms, and here is 1 ohms, and here is 1 ohms, and here is 1 ohms. Now in these cases, you want to stretch and you want to bend the way, you want to bend it. So then only you can see the story. If not, you feel like a kind of Greek. You feel like it's a Greek. It's a Greek. Right? Here it is 1 ohms. Hands up. Anyone found this answer? Hands up. Raise your hand. Somebody found this one answer. Answer. This one answer found answer. Anyone? This one found answer. This one. Now see. Now I told you that. I told you now what you can do here. Here what you can do. You can now from the joints you can bend it. Look here. Think my this hand as the circle. This circle as my hand. And these 5 fingers. Think this circle as my 5 fingers. And think this wire with 5 ohm resistance as my arm, right? See, currently my arm is like this. Currently my arm is like this. Currently my arm is like this. I don't know. Currently my arm is like this, right? Just bend the arm like this. Just bend your arm like this. So you are from this joint, you are bending this like this, right? If I explain pin, see, you are bending pin. See. I don't know. You can't see. Uh, look here. Look here. Look here. You are bending your pin like this, right? I will understand. You are bending a pin like this. If you do that, what you can do. Then if you bend this part opposite side, then you will get something like this. You will get something like this, right? You will get something like this. Am I correct? This is 5 ohms. So you can remove this one. Correct? Is 20 ohms something. Correct? I remove this one. Also, again same. Again, you can bend this wire to that side, right side. Right? You can bend the wire to right side. You can bend the right side. This is point capital B. Point capital B. Okay? Right? Okay? Okay, right? Right. But in this beginning stage, we could have removed this 20 in the beginning stage, right? So see this story, see this idea, right? Okay, this is how it was earlier. So you understand this circuit, this 20 ohm circle circuit is a loop. Why? This circle starting point and ending point is this point, correct? This circle with 20 resistance, starting point, ending point same. Other than this point, this circle has not connected to any other points in the circuit. This circle has not connected to any other point of the circuit. Only point is this one. Now then you can remove this automatically, right? Then your point B is here, right? The point B is here. And now what you can do, you can bend this point in this direction. Then it's easy. Hands up, how many of you understood why I removed that circle and why I brought point this side? Hands up. Raise your hands the way that what I have done is clear. Hands up so far. Raise your hands, how many of you understood I explained? Clearly? Clear, right? Now it's easy. Now these two are parallel. 10 parallel. Between these 2 points, these two are parallel. Equal is how much? 10 means equal is 5. And now can do. Now easy. Equivalent is 5. Then 5 in series. This R is 10 ohms. Likewise, this one. This one, see. This one also you want to follow same story. In here, you don't get any loops. But see what you can do here. See. Here what you can do. You can see. From this point, you can bend. From this point, you can bend this entire part to the right. Okay. I draw it. If not, you don't understand this one. So then you bend like this. You bend like this. Then if you bend like this, right? Then you are getting what? Then if you bend this side, here is your 1. Don't think the symmetric opposite, right? Now if you bend this one, this side, 1 is here. Then this one is coming here. Then my point B is like this. My point B is like this, right? Okay. Then here 2 is here. And here 4 is here. Am I correct? 4, 4. I just bend this circuit from this point right side. Then I can remove this part. Okay? Ni? Everything is okay? Ni? Now somewhat okay. These two are parallel. This is bit series. Now again, point B is in. Again, I can from this point. From this point, I can bend this inner circuit right side. If I bend this part, this circle and this line, right side. Again, one, a circle. Again, one, a circle, point B. Simple. It's 2, H2. Correct? Ni? Then can remove this one. Now it's simplified. Ni? See, look like very difficult. But finally, it ended with a very simple system. What is the answer? What is the answer? The answer going to be the equivalent of these two, 6, 6, parallel. Equivalent is how much? Equivalent going to be 3. This is equivalent, this is 1. And again 4 and this is 4 and 4. Huh? It should be 4, 4. Equivalent is 2. And again 1. Here it's 2, 1, 1. 2, 2 means equivalent is 1. Point B. These run series. 3 plus 1, 4, 5, 6, 7, 8. 8 ohms. Answer the story is clear answer. This idea loop story and this story clear answer. This idea is very clear answer. This idea is clear. Right? Ni? Clear. Likewise, the next one. You guys properly should do these things. Next one. So you should be able to identify the loops. But I explain the conditions. You should identify what is the loop. This is point capital A. Then point capital A should not be eliminated. It's 4 ohms. And here it's 2 ohms. And here it's 2 ohms. And here it's 2 ohms. And here it's 4 ohms. And here it's going to be 2 ohms. I will ask a question. You want to find the equivalent resistance between A and B. Raise your hands, how many of you say? Raise your hands, how many of you say? Sir, this part is a loop. Sir, this part is a loop, hands up. How many of you say that part is a loop, hands up? Raise your hands, how many of you say that part is a loop, hands up? That part is a loop, hands up? It's a loop, why? Starting point, finishing point, this is the same point. Other than that, this circuit has not connected to the main circuit from any other point. This part has not connected to the main circuit from any other point other than this point. Then it's a loop. If it is a loop, you can remove that. If it is a loop, you can remove that. Remove it. We can remove. And remove the loop, the pending will be, the remaining circuit will be like this. This is point capital A, point capital B. Here is 4 ohms. And here is 2 ohms. And here is 2 ohms. Then see now. Now you want to find the equivalent resistance between A and B. Is 2 ohm in series. 2 ohm, 2 ohm in series. They have a 4. Right? So then AB, these two in series, 4 ohms. These 4 ohms are parallel. Equivalent is 2 ohms. Simple. Likewise, next story. Right. Finish writing, hands up. I'll tell you the next point. Once you finish writing, raise your hands. I will tell you the next point. Likewise, some points will be added. Right. So once you finish, raise your hands, then we can go to next story. Right? The next point, write down. Next point. Next point. Right? If there are any resistors not connected, if there are not resistors, if there are, if there are any resistors, if there are any resistors connected in between the terminals, in between the terminals, at which equivalent resistance is to be found. Equivalent resistance is to be found. Equivalent resistance is to be found. And no current passes through those resistors. 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 Right? Then those resistors can be removed from the circuit. Then those resistors can be removed. Then those resistors can be removed from the circuit. Those resistors can be removed from the circuit. Okay. Right. Okay. But that story is like this. That story, look here. Now I raise these stories. This story. Just consider a circuit like this. A circuit like this. Now here, this point is point capital A. This point is point capital B. So you want to find the equivalent resistance between these 2 points. There are resistors. Here there's a resistor 10 ohm. There's a resistor here 10 ohms. And 10 ohms. And 10 ohms. See the story. See, now I'll ask you a question. Right? This is your circuit. Normally remember, current passes always through kind of what? Closed system. there should be a path to continue the current flow, right? When current notice that there's a path, that path is not fully connected. There is a path, there is no any path after a certain point. If current notices like that, for an example, you are going to highway road, and suddenly what happened? Highway road has broken into two parts, right? That highway road is broken into two parts. If there is a bridge, that bridge is fallen down, right? That means can you go even though there's a path, since the bridge is fallen down, there is no any proper path between those two roads. You can't go. Likewise, in order to flow a current, there should be a continuous path. If current notices, if I travel this path, there isn't any continuous path in this path, then current won't flow. So therefore, remember the resistors in those paths, you can remove that. Resistors in those paths, you can remove that. Now see here, just think current is starting to coming from A. This current is coming from A, and just think current leaves from B. Current is coming from A, current leaves from B. Just think like that. Now this current is coming from A. This current is, let's say, I current passing. Then what happens? Then currents notices there are two possible paths. Then this current breaks into two sub currents, I1, I2. Current splits into two, I1, I2. Just look at this I1 current. This I1 current is flowing in this 10 ohm resistor. This I1 current flows through the 10 ohm resistor, and I1 current again after coming to this junction. After coming to this junction, I1 current says that again there are two possible paths. But do you think ratio and harmony we say this I1 current will split into two currents, and ratio and harmony we see there will be a current passing through this path and so. Ratio and harmony we see there will be a current passing through this path and so. Sir, there won't be any current passing through this path and so. Sir, there won't be any current passing through this path. Because why? This path is not closed. Right? So therefore remember, whenever you see resistors in those parts, not current flowing parts, non-current flowing parts, you can remove those resistors. See? Same. Do you understand? Then now you can find the equivalent. You can remove these two from the system. If you remove these two from the system, your system will be simplified. System will be simplified like what? Point A, 10 is your system. Point B, 10 ohms, 10 ohms, 10 ohms, 10 ohms. Now consider these 2 points. These two in series, 20. Consider these 2 points. These two in series, 20. Consider these two parallel, 10. Right? Here it's 10. These two parallel, 10. Point B and point A. Result going to be 20. Result going to be 20. Nice story, ne? Nice story. Likewise, find the answers. Next one. Find this. Likewise, find this. Find the equivalent resistance. Find the equivalent resistance. 2 ohms. It's going to be 4 ohms. 4 ohms. 4 ohms. 6 ohms, 18 ohms. 6, 18, 5 ohms. Find the answer. That's another one. There is another one. This is a point B, point capital A, point capital C, point capital D. 10 ohms, 10 ohms. 10, 10, 5, 5, 10, 6, 2, 4, 6, 6, 2, 4, H1, it's 3. Always you want to find the equivalent resistance between A and B. Yeah? Should find the equivalent resistance between point capital A and point capital B. This is 3 ohms. And here also there is 1 ohms. 1 ohms. Find the answer. 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 Finish the answer. Finish doing these 2 questions, raise your hands. Finish the answer. Also finish doing these 2 questions, raise your hands. Not difficult. I told you that story. If you notice the path is not computed, and if you see in a path, resistors in a path where current does not flow, if you see the resistors in a path where current does not flow, you can remove those resistors. You can remove those 2 resistors. You can remove those resistors. Just think properly. Just think properly. Just think properly. Just think properly. Finished answer? Finished. Anyone finished answer? This is easy. This is one finished hands up. This one finished hands up. This one finished. This is not difficult. So you can remove that current is not flowing to this 5 ohm resistor. No any path. If no current passes, means remember you can remove the resistor. Remember, write on point. Red color being important. Write down. Red color being important. In a circuit, in a resistor circuit, in a resistor circuit, if no current passes through a resistor, if no current passes through a resistor, if no current passes through a resistor, comma, then we can remove that resistor from the circuit. Then we can remove that resistor from the circuit. Then we can remove that resistor from the circuit. Okay, right. Can remove this one. Then 2 and 4 series 6. 2 and 4 series 6. And 4 and 4 series 8. And 18 and 6 series 24. 24. So then different people can do different ways. Now one can consider these two. Right? So if not, one can consider these two. 8 and 24, they are parallel. 8 into 24 over 8 plus 24, 32. If you divide by 8, 1, here again it's 4, 6. The result of these two going to be 6. These 6 and 6 parallel. Answer is 3. Okay. Here see, simplify as much as possible. 10 and 10 parallel. Equivalent is 5. And then consider these 2 points. If you consider these 2 points, 5, 5, 5, 15 series. 5, 5, 5 series. 15. 15 and 10 parallel. 10 into 15, 10 plus 15, 25. Here it's 2. If I divide by 5, it's 5. Here it's 6. Correct? The equivalent of these two resistors in parallel, 15 and 10, equivalent one is going to be 6. Equivalent one going to be 6. Right? 6. Now see, now I want to find the equivalent resistance between A and B. But when you see the C and D, current does not flow through C, current does not flow towards D. We can remove 1 ohm, 4 ohm. We can remove this. Somehow, almost we came to the story. Now can, right? Now you can do this one. Now what you can do, you can bend this. Now these two are vertical. This 3 ohm is vertical. Like a chair. Think these are the forces of a chair. These are legs. 2 legs are vertical. What you can do, you can bend your leg like this. Bend this leg also like this. Look from the top. If you feel uncomfortable, look from the top. Then the leg B is 1. Then this leg A, that is 3. This is going to be the 6. 6. Then 6. Then 4 is going to be 2. Simple. 6 plus 4 plus 2, 12. Series. These 3 series. 6 plus 4 plus 2, 12. Series. Nice, simple. 12 and 6 parallel. 6 into 12, 6 plus 12, 18. 4 Here you are getting 1, here you are getting 4, here you are getting 3. 4 plus 1, 5, 5 plus 3, 8. B, A, B, 8. It is the answer. Simple. Clear, right? It's clear. It's clear. Right. It's clear. Right. Up to now, everything is very clear answer. Up to now, everything is very clear answer. Up to now, everything is very clear answer. Right. Now we'll do one last story. Almost finished. But we have to do one simple story, some stories. Write down now. Write down kind of subtopic. When zero resistance wires are connected between resistors. When zero resistance wires. When zero resistance wires are connected between resistors. When zero resistance wires are connected between resistors. Write down below. Write down below. The voltage at the points. The voltage at the points at which. The voltage at the points at which. The voltage at the points at which zero resistance wires are connected. The zero resistance wires are connected. Are same. Are same. Full stop. Then we can tie those points together. Then we can tie those points together. Then we can tie those points together without having any impact. Then we can tie those points together without having any impact. We can tie those points together without having any impact. Okay, look at the story. This is a very important story. Just tell me now, up to now, every point that we discussed and the way how we found the equivalent resistance. The story is very clear. The story is crystal clear. Everything is clear. Now the story, zero resistance wise. Normally, I will tell you if you understood the beginning stories, how the way we started conductors. Conductors means when you consider any conductor, when charge is flowing through any conductor, there's a barrier. There's a barrier, obviously. If we can measure that barrier quantitatively only, we have defined the physical quantity called as resistance, right? Now, then you might be wondering, sir, I have a doubt. Now, just consider any this circuit. So you have drawn these straight lines, and you have drawn. You used this symbol to represent resistors. Now, my question is, these straight lines are conductors, right? They are kind of wire. It can be copper or it can be iron. They are kind of conductors. This symbol is a kind of resistors. It's a kind of equipment to create resistance. I understood that idea. My concern is these are conductors. The straight lines are conductors. So they are also having a kind of resistance, right? As you explained in the beginning, these conductors that you represented in straight line also should have a resistance. Am I correct? Actually, yes, they have resistance. Those wires, these straight line wires, they have resistance, obviously. But what here we do is we are assuming that comparing with the resistance of these resistors that you connect in the circuit, comparing the resistors that you connect in the circuit, the resistance of the conductor wires are negligible. But in the real scenario, yes, there is a resistance. But if we are going an assumption, we are going with an assumption, comparing with the resistors comparing the resistances of the resistors that you connect to the circuit, resistance of the wire, resistance of the conductors are negligible. So therefore, we can call them as zero resistance wires. Therefore, we can call them as zero resistance wire. So you can call these wires as zero resistance wires. Okay, that story you want to understand. You understood. Now let's consider a resistor circuit like this. This circuit like this. Very careful listen. Resistor circuit like this. Look here. Now there are three resistors. Seem like they are in series. See how the way they can make you into a trap. So when you look at these three resistors, you also feel like they are in series. So you also think like they are in series. Right? This one and this one. This one. Let's say they are R1, R2, R3. This is R1, R2, R3. This terminal is terminal A, terminal B, and also this circuit includes two zero resistance wires. This circuit includes some zero resistance wires like this. Look here. Look here. This wire is including some zero resistive wire. Very carefully, listen. It looks like these three are in series, but it's not true. So the way how they can trick you, right? Okay. Now normally, when you feel the circuit becomes complex, the best thing is by using different colors. Try to identify points having same voltage. Try to identify points having same potential. Right? Okay. This is what I'm doing. I will ask you a question. Just raise your hands. Okay. If it is correct, raise your hands. Okay. My question is, raise your hands. How much do we say the voltage at this point and the voltage at this point are same answer? Raise your hands. How much do we say voltage at this point and voltage at this point are same answer? Till they meet resistance, right? Till they meet resistance in a conductor. Now these are, now see, now this line, these lines are zero resistance wires, right? So till they meet resistance, all those points should have same voltage. Sometimes you can't identify that. That's why I'm telling, now some people by the experience, some of you can tell, sir, these 2 points should have same voltage. These 2 points should have same voltage. Some people can't identify that. In that case, what you do, take some colors, use different colors, right? Then what you do, you just color it, So when you just color it, see, till when I consider voltage point capital A n, till it meets resistance. If I say voltage at point capital is 5 volts, what is the voltage at this point nearby the resistance R1? 5 volts. You can color it 5 volts. Through this 5 volts, 5 volts, 5 volts. Right? This point to the 5 volts. Till they meet resistances, voltage going to be 5 volts. 5 volts. Right? If I ask you, let's say voltage at point capital A for an example. For an example, voltage at point capital A is 5 volts. What is the voltage at this point? 5 volts. Why? All of them are in blue. And all the points are in blue should have same voltage 5 volt, 5 volt, 5 volt, 5 volt, 5 volt, 5 volt. Likewise, if you use a different color, red color, voltage at point B, let's say 2 volts something. All these points should have same voltage 2 volts, 2 volts, 2 volts. Same voltage, same voltage. Okay, right. Okay, right, okay. Okay. Now, if once you color it, you can come to a conclusion. Once you color it, now I will tell you what we do normally. These when there are zero resistive wires are there, I will tell you what you want to do. But currently, you almost have solved this question. You know what is the equal resistance. Raise your hand. Somebody will say these resistors R1, R2, R3 are in series and sum. Just consider the terminals of R1. Consider the terminals of R2. Consider the terminals of R3. Raise your hand. Somebody will say R1, R2, R3 are in series and sum. R1, R2, R3 are in series. R1, R2, R3 are in parallel and sum. R1, R2, R3 are in parallel. I taught you one point. If the resistors are in parallel, can remember? I taught you potential difference same. If the resistors in parallel, if the resistors are in parallel, I taught you that when you color it, right? If the resistors are in parallel, potential difference same. When the resistors are in parallel, I taught you potential difference across each resistor are same. Right? See, this resistor also, the terminals of this resistor is in blue and red. Let's say blue voltage is 5 volt, blue is 5 volts, red is 2, 5 minus 2, 3 volts, potential difference. This resistor, terminals are in blue and red. Blue is 5, red is 2, potential difference is 3. Blue and red. So remember, see, same story here. R1 blue and red, R2 also blue and red, R3 also blue and red. Then this should be a parallel circuit. But still you are not compromised. Still you are not convinced. Still you don't accept these three are parallel, right? Okay. That's what they are telling. These three should be parallel. R1, R2, R3 should be parallel. But see what I'm doing. See what I'm doing. They told us whenever you see zero resistance wire, whenever you see zero resistance wires, what you can do, you can remove that zero resistance wires by tying those 2 points together. Okay, I will tell you. Just think, this blue color zero resistive wire is connected from this point and this point. Am I correct? Right. This blue color zero resistive wire is connected between this point and this point. So what you can do in such cases, you know, this point and this point have same voltage. Blue, this point has same voltage. This point will mark it as point capital D something. So we know that voltage at point capital A and voltage at point capital D must be same. In that case, they are telling, since these 2 points have same voltage, they are telling, remove the zero resistance wire and tie these 2 points together. Tie those 2 points together. Tie point capital A and point capital D together. So how can we do that? If I remove this, right? If I remove this, right? If I remove this, okay? I think you have written this one, huh? Write this one. Draw this one quickly. Draw this one quickly. Draw this one quickly. Draw it quickly. Draw it quickly. Finish drawing answer. Finish drawing and hands up. Finish drawing answer. Finish drawing. Quickly. Done. Hands up, hands up. Right. Look here what I'm doing. What I'm doing. They are telling if there are zero resistance wires, voltage at these 2 points are same. They are telling remove this zero resistance wire. Remove the zero resistance wire. Yes, I remove it. And they are telling tie point capital A and point capital E together. How are you going to tie these 2 points together? These are wires. You can bend the way that you want. You can bend these wires the way that you want. See what I'm doing? I'm bending this wire. I'm bending this wire like this. See the way? I'm bending. I'm bending. Then I'm bending. Right? I want to bring point capital A. I want to touch point capital A and point capital together. I want to tie point capital A and point capital together. I'm bending the wire. Right? Likewise, likewise, likewise. Finally, see, finally, see, finally, R1. This point is some finally here. Point capital A. You notice what I have done actually? You notice what I have done actually? I bend that wire and now point capital A and point capital D coincide. Point capital A and point capital D coincide. Now you agree R1 R2 parallel, right? You agree R1 R2 parallel. Hands up. Up now everything is clear. Hands up. Up now everything is clear. Hands up. Again, whenever you see, these 2 points having equal voltage. You know voltage at point capital C, voltage at point capital D are same. Correct me? These 2 points are same voltage. These 2 points are same voltage. Then they are telling, connect this point and this point together. Tie these 2 points together. How can I tie these 2 points together? See. How can I tie? Tie these 2 points together. Remove the wire. Tie these 2 points together. Now see point B. I want to tie point B with point C. Right? See what I'm doing. Now R3 point B. R3 point B. Right? This is R2. See. R3. No. This point I'm connecting here. Finally. You understand? Now your point B is here. Point C and point B same. Finally, I noticed that. Right? Finally, I noticed that. See, if I do the final story, I'm understanding. I understood. Finally, R1, R2, R3, they are. This is B, if not C. This is A, if not D. They are parallel. Parallel. Clear answer. Everything is very clear answer. Generally, hands up. Everything is very clear. Right. I think so. We have few more to go. And right. So we'll discuss the stories upcoming days also. We'll finish electricity and magnetic field soon. Then we can do a lot. Right. So we'll stop the classes for today. And tomorrow night and Tuesday night we have classes. Right. So then we'll see you. Bye. Have a nice day. Redo it again. Have doubts, ask. And see you. Bye. Have a nice day. Good night.